Hi everyone. In this lecture, we are going to discuss about the term frequency and inverse document frequency. First of all, why it is so important, the term frequency and inverse document frequency, right? So because the earlier methods that we discussed about the bag of words approach, right? So it does not capture the whether the word is a frequent word or whether it's a rare word, right? So if a word appears in many times in the document, we say it is not that important, right? So let's say if you are trying to do a movie analysis, like many people writes the movie in many places, right? So hence that particular movie as a name, it may not be important when you are capturing the sentiment behind this movie, behind this review, you could say, right? So if that means that if the word appears many times in every document, or if the word is very rare, then there is should be a differentiation between this very frequent term or very rare term. So if let's say if the word appears only in few documents, but if the same word it's not appearing in the other documents, then we should give us some weightage to that particular word, right? So that is what is the bag of words that does not take into consideration, depends on the frequency, or depends on the whether the word is a rare word, or the if the word is appearing in many documents, all these pattern it does not capture. So to overcome that, we have a term frequency and inverse document frequency. So term frequency and inverse document frequency, it captures the how the word is frequent or rare, and depends on that we give a weightage to that word. That is what is the term frequency and inverse document frequency. So this creates a vector in terms of the multidimensional space, which represents a little contextual relation, right? Little bit contextual information rather than the just a frequent count, right? So that is what is the term frequency and inverse document frequency. Let's go in detail what is the term frequency and what is the inverse document frequency, and how these two go together when we are trying to calculate the word embeddings, right? That's what we will study in this particular lecture. So first is the term frequency, which is called as a TF, usually term frequency. Right? So the term frequency of any word, right? We can say this is with respect to every document we usually calculate, right? So with respect to, let's say, document 1, right? Then we say that how many times the number of times of this word in the document divided by the total number of words in the document, in the same document, right? So this is what is the term frequency. Or like we can also write this as a frequency of the word in the document divided by the total number of words in the document, right? So how do we calculate over the few examples we will see here? So the first example is, I love dogs and dogs are cute. And then similarly, cats are cute. Third example is, dogs and cats make great pet. Right? So these three are the, let's say, assume that these three are the sentences or the documents, 3 documents. So now if we come up with, like, let's say if you apply a text cleaning and then stemming limitation, right? And then we get the, after you perform a tokenization, we have a love, dogs, which is dog, dog, and cute. This is how you get. And similarly, the second sentence or second document, we get cat and cute. And the third document you get is dog, cat, make, great, and pet. So these are the tokenizations after you perform the tokenization, right? So now once you have that, let's say example, we calculate the for each word, like you first make a vocabulary is nothing but building a vocabulary entire this one, right? So you have the find out the all the unique terms here and then make a your own set of the vocabulary and then make it as a columns, right? So example, now love, dog, cute, cat, then dog cat is done, then make, great, pet. This is the total unique words in the entire documents, or here is an example 3 documents we have. So let's say the sentence 1, sentence 2, sentence 3, the similar format that we have discussed about, right? So we have the term frequency, like in the same previous method we have discussed the backward first, the documents will become rows and then the columns will become the vocabulary of the words, you can say. So then the value that you calculate is the term frequency of the love here. The term frequency of the love is the number of times of the word. So how many times out of total 4 we have a 1, so it is a 1 by 4. And similarly dog, we have a 2 times in this entire document, so 2 by 4. Similarly cute is 1 by 4 and remaining is 0, 0, 0, 0. And then we have the cat and cute. So we have cat and cute, we have 1 by 2 and then 1 by 2. The remaining is 0, 0, 0, 0, 0. Right? So that's how it is. And similarly dog, cat, make, great, pet. So if you see dog, 1 out of how many words? Total 5 words. So hence the third document will become similarly the 1 by 5 and then 0, cat is 1 by 5 and make is 1 by 5 and great is 1 by 5 and pet also 1 by 5 and then love is also 0. We don't have anything. So this is how term frequency matrix is. So this complete matrix we call as a term frequency matrix. So TF matrix we call. So term frequency matrix. As subsequently we talk about how inverse document frequency is calculated, right? So what is a inverse document frequency? So inverse document frequency is IDF, which we denote, right? Inverse document frequency. Right? So what is the inverse document frequency? So inverse document frequency is nothing but based on the frequency of the word, right? We give a weightage, right? So if the frequency is very high, which means that if the word appears in every document, that means that we give a lower weightage. Right? So that is what is inverse document frequency. And if the word appears very rare in only few documents it appears, then we give a higher weightage. That's what is inverse. That's where it comes as inverse proportionate. Right? So now the formula for the IDF of the word is logarithmic of capital N, which is the number of documents, divided by number of documents containing the word or this word particularly, right? So if you are calculating any particular word, what is the inverse document frequency? That is nothing but logarithmic of total number of documents, capital N, divided by the number of documents which has this particular word or which contains this word, right? So that is where, so we will talk about with certain examples, the same examples that we discussed with the term frequency. Here also we discuss with the same example, the sentence 1, sentence 2, sentence 3, and then we will calculate it. Once we have this example, right? I love dogs, dog circuit. Once we have the text processing and then we get this words, right? Since the same way how we calculate the term frequency, now let's calculate the inverse document frequency. So for the love word example, logarithmic of capital N, which is capital N is nothing but number of documents here. So we have a total number of documents is 3, you can say. So So log of 3 divided by, let's say, example, log of 3 divided by the number of documents which has love. So this is IDF of love, right? So now logarithmic of 3 divided by 1, we have C log 3, which will become 0.47, right? And similarly, now IDF of, you can say, dog. So dog is log of total documents is 3 again, 3 divided by, you can say, how many documents which has this 1 and 2 documents dog has, right? So log of 3 by 2, which is log of 1.5, which will become 0.179 something, right? So example like this. So now you put this, all these values for every document onto this matrix of inverse document frequency. So love will become 0.47 and 0.179. Cute also will become log of 3 by 2, which will become 0.179. Cat is, since we don't have here, 0, 0, 0, 0, right? And then we have sentence 2, which is cat. Cat is log of 3 divided by how many documents which has, so 2 documents it has cat, so hence log of 3 by 2, which is 0.17, is 0.179. Similarly cute also 0.179. So 0, 0, 0, 0 and 0, right? So now this is how it look like, right? And then for the document 3, dog appeared in 2 documents has dog, and log of 3 by 2, which will become 0.179, and this will become 0. Cute, anyway, cute will be 0.1. So cute right now we don't have, right? Cat we have. Similarly 0.179, make is only 1, so it has become 0.47, 0.47, 0.47, because everything it has a only 1 document. So now you can see that, right? If the word love, it's very rare, that means in out of 3 document it has only at one place, 1 document has this love, so hence it has a higher weightage. So if the word only appears in few documents, that has a higher weightage. And if the word is really very common, let's say if all the document has, like all 3 documents has a, you can say if the word appears in all the documents, log 3 by 3, which will become 0. So we nullify these weights, we completely give a 0 weights to this particular in the complete idea of inverse document frequency. So now, so you can relate this, right? If the word appears heavily, means very frequently in every document, we give a low weight. If the word appears very rare in only few documents, then we give a higher weight. This is where the IDF is completely different from bag of words approach. So that is where this is where the key difference between this one, right? In the term frequency, now based on the frequency of, if the frequency is higher, we give a higher weightage, and if in the inverse document frequency, inverse proportion, if the document is appearing too many times, we give a lower weightage. If the word is very rare in few documents only, then we give a higher weightage, right? So now we club this inverse document frequency and the term frequency, we combine, and then we make a final matrix, which is a embedding matrix, which represents the word in this TF-IDF space. So once we have the term frequency calculation for the 3 sentences, and similarly inverse document for the 3 sentences, and now we calculate the final vector, which is called as a TF-IDF vector. So how do we calculate this? For every cell to cell, right, we multiply them, right, the term frequency into IDF inverse document frequency, we multiply, and then we get the final vector. So let's do that. So we see here term frequency, we see here inverse document frequency of the calculation, and then we get the final term frequency and inverse document frequency, which is multiplication of these 2 matrix. So now 0.47 into 0.25, which will become 0.1175, and then 0.5 into 0.179, which will become 0.089, right? And then 0.25 into 0.179, which is 0.125 into 0.179, which will become 0.044, and then 0 into 0, 0, 0, 0 and 0. So we have this the final matrix for the document 1. Similarly, for the document 2, wherever like 0 into multiplication 0, then 0, then we have the cute 0.5 into 0.179, which will become 0.089, and similarly 0.5 into 0.17, similarly the same one, 0.089, right? And then we have 0, 0, 0, right? So this is for the document 2. Similarly, for the document 3, we will calculate. So 0 into 0, 0, and 0.2 into 0.179, which will become 0.035, right? And now 0 into 0, 0, and then 0.2 into 0.179, the same value, 0.035, and now 0.2 into 0.47, which will become 0.094, and 0.2 into 0.47, 0.094, and similarly the same 0.2 into 0.47, which is 0.9094. So now we see the final tone frequency and inverse document frequency, which is a vector now, which we have got, right? So this is the vector now we use for further applications. Like let's say if you are trying to develop a sentiment analysis, you get the x, y, here x and y. So example, yes, x1, sentence 1, sentence 2, sentence 3, sentence 4, and this is the training data. Now we have a label 1, 0, 1, 1 example. Now the sentence 1, you break down into term frequency and inverse document frequency, which is the numeric values which we get, and this has transformed into, let's say, example x into y. If you see the data, right, we have the, let's say, some 0.5 comma 0.2 comma 0 comma 0 comma some vector, right? So like this we have the values, and similarly some values here, and here also some values, and we have the 1, 0, 1, something like this. So we have a vocabulary. X is actually turned to this love, dog, cute, cat, make, great, pet. So x1, x2, x3, x4, x5. So which will become x1, x2, x3, x4, xy, x6, x7 here in this case. And then we have a dependent variable as well. So now you can build your own any machine learning algorithm or XGBoost or a neural networks as well. So in order to classify whether there is a sentiment and whether positive or a negative or a neutral or whatever, right? So depends on, like now earlier we had a sentences, now we got the term frequency and inverse document frequency, which is a number values, which is really now you see wherever the word actually the rare, and then it has appeared in only few documents, now you see higher weightage. You can see there is a higher weightage because love has appeared on only one document, and which is very rare, so it has, you see there is a higher weightage. And similarly now you can see the dogs are appeared in the, you can say in the this one in the first sentence and second sentence, and based on the term frequency and inverse document frequency, you can see there is a higher weightage in the sentence one because of the term frequency pulling up, and then there is a less weightage. But if the word appears in every document, you get the inverse document as frequency as a 0, so which means that you multiply TF with IDF value, which will also become the 0, so hence that will be nullified, right? So the weight completely it will be 0. So that's how TF-IDF is calculated. In the next chapter, we are going to discuss about word-to-vec, which is more advanced compared to the TF-IDF as well. So we will see what are the advantages of the word-to-vec, and then how do we, what are the disadvantages of the TF-IDF, and then how do we overcome using the word-to-vec in the next chapter.